My name is Charles Pretzer. I am a technical architect at NGINX, working on our professional services team, and I focus specifically on microservices and helping our customers to develop their applications using microservices, and as we'll see, also to help migrate monoliths to microservices. I see a few familiar faces who are not my NGINX coworkers, and I think that's probably because I've seen some of you all on site. So it's good to see you again, and I hope that this is helpful for you. What we're going to talk about today is I think I got the longest title of the entire conference, so I'm pretty stoked about that. This is a pragmatic maturity model for adopting microservices. And we'll see how this ties directly into some of the conversations that were, or some of the presentations that were in the keynotes today, as well as how it, and this wasn't by design, but with the last speaker who was in this room, Christopher from Comcast, had some really good information about DevOps and microservices. And so this is the same direction that we're moving, building an entire system for microservices. Oftentimes when we talk with customers, they don't know where to begin, or they've started and have found themselves a bit lost with what the next steps are. So as we go through this talk, while some of the data, or not data, some of the information is going to be similar to what we've seen already, there are a couple of things that are a couple of questions that I think are important to ask yourself. One is, where are we in this journey? As you know, the theme for this NGINX conference is Journey to Microservices. So first is, where are we? And that also implies, where are we going? And then when we take those two together, the natural kind of inferred question is, how do we get to where we want to be? But I want to challenge you to extend that in your mind a little bit, to really understand that it takes a full plan to get to where you want to be. And we'll see, again, with the full CI/CD pipeline, and also taking into consideration that things don't always go according to plan. So I've specifically worked with customers who have struggled with issues along the way, especially because this is such a new field. And so one of the things to also think about when writing your plan is, what are our contingencies when the plan goes sideways? So these are questions that I hope that you can answer at least by the end of the conference. We'll certainly be around to help you talk through some of these things if you're already finding that you're running into issues, or if you want to discuss some of these topics further. So I have challenged myself with like 30 slides and 35 minutes of conversation. So I'm going to push through these things. We'll have a Q&A at the end, but I'll also be wandering around throughout the rest of the conference so that you all can ask questions. And please feel free to raise your hand and let's make this an interactive dialogue if there are questions along the way. So with that, here we go. We'll talk about just briefly go over some definitions and concepts. Probably most of these will be familiar to you already. Then we'll go into really the heart of this conversation, which is the principles of modern application development. We'll take a look at some of the microservices network architectures that we've developed at NGINX. And then we'll look at the components of a pipeline for continuity, and that continuity is for CI/CD. And then we'll put it all together, and hopefully there will be time for questions. So, definitions and concepts. This is our journey to microservices. The first thing we're going to talk about is, what is a microservice? And more often when I speak with customers, they're not so much curious about what a microservice is, but the question we really get is, how big should a microservice be? Who's already started building microservices, either through migrating a monolith or greenfield applications? We've got a couple of people in here. And so I imagine at some point in time, you've asked yourself, how big should these things be? A really good definition that I've found is that a microservice should be not so big, or it should be big enough such that refactoring it is easier than rewriting it. And when we're writing some of our microservices or helping customers to write those, or even in some of my personal projects, I'm trying to stick to that rule as much as possible. So if I need to change something, I'm not throwing out a bunch of code, I'm just modifying what's already been written. DevOps. developer operations. And Chris, in the last presentation, made a really good point about sometimes developers just don't want to do operations. And I agree, and what we'll see as part of the principles of a modern architecture is that developers should be allowed to be developers. And I heard a really good example about this. So developer operations takes the workload off of developers so that they don't have to manage their own infrastructure as they're developing. They can focus on the code, which is what we want them to do because that's what their job is. They shouldn't have to worry about maintaining architecture or infrastructure. So now we're getting into some of the key concepts that we discuss, that we talk about at NGINX. Especially when it comes to building our microservices and understanding what it is that make all these pieces work together. So service discovery is pretty significant. So when a new service is added to an environment or instances of services are added to those environments or to an application, it becomes very important that the router, in this case NGINX, knows where to send those requests as they come in. And so NGINX itself, NGINX Plus, uses DNS as a method for service discovery, which is very powerful because DNS has been around for so long and because it's so simple. Once we have been able to discover those services, the next key important part is to be able to load balance across those. So it's one thing to have services and know that they exist, but if we're not properly load balancing traffic across those instances, the service discovery doesn't really give us any benefit. So when we talk about load balancing, that ties hand in hand with the service discovery piece, where now that we know that we have 10 or 20 or in some cases hundreds of instances of a single service, how do we know that we're properly load balancing across each of those such that no one service is getting more traffic than the other and that we're getting the best performance that we can? And also, this can tie into a little bit of the cost savings that microservices deliver. If we find that we have just perfectly even distribution across all of our services, but a lot of them are idle, we probably know that we can scale down those instances a little bit so that we find the right number to optimize for our services not being overloaded, but the traffic is being routed in an efficient manner. So that's the load balancing piece of some of the concepts of microservices or of the architecture. Monitoring has always been an important part. We need to know which of our services are running and how healthy they are. More recently, conversations have been evolving around this concept of observability. Now, observability, I've heard a few different definitions of, but for me, observability just takes that holistic approach to the system. Monitoring, again, is important for understanding the health of those services. Where observability comes in is being able to understand when a request comes in, a normal request. We can say if you're logging into a site that uses microservices, and this is a good example of that here. We see that the first place where the request is going to go is into this authorization auth proxy service. This is actually a real-world application that we built at NGINX called the NGINX application. It's available on GitHub as an open source project. It's github.com/nginxinc/MRA-ngenius. I will be glad to speak with you about this on the floor because we put a lot of time into it, and our goal is to be able to help you to build your microservices. In this case, the observability piece is understanding when that request comes in, how it bounces around through each of the services, where it ends up, which services touch it, if there's any latency there. There's some very good software for understanding the time series of a request as it goes through. One of the features of NGINX Plus that we released last year is the ability to uniquely identify a request. So in this case, we would configure that auth proxy service to assign a request ID to the request that comes in. And then through the NGINX directives, we can then know that if that ID is already assigned, none of the other services will try and assign that. And then from there, we can log that out And so you can see how we can build an audit trail of how that request moves through the application. So there's still a lot to go through on observability, and a lot of companies are focusing on building out this infrastructure. You've got companies like Lightstep, and I think Datadog is here, and they're I'm sure that they have some very good initiatives towards not only the monitoring but also the observability. So again, this is one of those really big topics. I think I could probably talk about it for a while, but it is key to understanding not only the health, but the performance and the nature of the system, of the application itself. And then another piece that we want to talk about is an API gateway. We heard some really cool news this morning about how NGINX is now moving into the API management part of the API gateway. We have for a long time been able to use NGINX as an API gateway based off of its location-based routing functionality. Now with the API management piece, it'll add that much more control over the API gateways that folks are creating. And the reason that this is important in my practical experience is that as folks are creating microservices, what they're ultimately creating is a series of endpoints that are defined in separate pieces of logic, blocks of code. NGINX acts as the means to route that traffic through a single entry point to each of those services. So now your mobile devices, if you can now use those API endpoints, web clients, if you're using something like Ember or Angular or I think I dated myself. I don't know if people are actually using those anymore. If you're using React, that's the cool one. Yeah, if you're using those, you can now begin to create your web clients that interact with this API gateway to get those responses back. So now you've got a single consolidated mechanism that multiple clients can use. And this also works for external clients. So if you provide a third-party API that is not only your own API that your own clients will use, we now have like I said, a single gateway and entry point so that any client can use this. Now there are some questions there about authentication and authorization and who should be rate limiting is a big part of API gateways, especially if you consider somebody or a company like Yelp or Wonderground is one that I like to use, where they provide, you have an access key and you can access that endpoint as much as you want. Unfortunately, there are folks out there who think it's funny to take advantage of those, and so something like rate limiting becomes very important for the API gateways. So those are basic definitions of some concepts that we'll be talking about as we continue to move through this conversation. So now as we dig into the more meaty part, it's really the principles of modern application development as we see them at NGINX. And I hope other people see them the same way that we do, but we really are focusing on some key principles. Keeping the pieces small, keeping them networked, and developer-oriented. And so let's talk about small to begin with. So we talked about microservices when we defined them. How big should a microservices be? Again, in my opinion, the smaller the better. Some have taken that to an extreme, and we've seen this serverless implementations of some functions as a service, which I think is very interesting and has a very powerful place inside of an application, mostly for running jobs or like batch one-off types of work. When we're talking about building a microservices application, we often think of the services as we need them to be around for a while, or at least not as short as just running a function and then exiting. So when we talk about our microservices, we want to make them small, makes them easier to write, makes them easier to debug. If we're talking about the Agile timeframe guidelines, oftentimes we talk with customers who are working in sprints that are anywhere from two weeks to a month. And within that sprint, they define their goals. They understand how building multiple sprints together in a series will result in the application that they want to build. And so the iterative nature of building these, of using sprints to develop these applications allows for quite a few things, actually. One is, again, a smaller cognitive workload on engineers so that they know that in this sprint, for a particular microservice, maybe they're building out one particular feature that has to do with security. So that they can focus simply on that. They can write their tests for it. So we're building tests as we're writing these applications. So keeping these applications small using agile development processes have really contributed, we're even the forerunners, I'd say, to building microservices applications. Again, we want to make sure that our developers can focus on building the feature by clearly defining within a given time frame what those features should be. And again, reducing the size of the code base, fewer lines of code, means engineers who are working on the same code base can fully understand what they're building. And this is important to me because in my experience, I've worked on monolithic applications where I needed to write a helper function or helper method. And the code base was so large that I could look through the code base that I'd probably find some sort of helper method that did what I wanted it to do. It was a daunting task to be able to go through all that code. Now that we have these smaller bits of code, these microservices that can be anywhere from, from one file to maybe 10 files, it really helps us to understand what is and is not in the code base, so you can actually reduce the amount of code. So reducing the size of the code base itself actually removes redundancy and duplicate code. And again, this is easier to debug, easier to review. If we're doing pull requests, engineers can go in and say, I'm going to mess this up, but I know that there's like, if you give me 100 lines of code, I'll find 8 bugs. If you give me 1,000 lines of code, I'll find 1 bug or something like that. So there's a scale where, as an engineer, being able to read through code, fully understand what it's doing, how different classes or different classes or functions are relating to each other, really being able to understand how everything ties together and break it down in such a way that we're not recreating code. And then iteration. So we iterate. That's, as engineers, we want to make sure that we are following this agile development process so that sprint over sprint, we're contributing to the functionality of the code and not adding bugs, and that we're shaping the code in the way that we need to until the requirements are met for our application. The next topic, and I touched on this at the beginning as well, is being developer-oriented. The use case that I saw for this specifically was when, so developers should be allowed to develop. This doesn't apply strictly to engineers. I was working with a company recently where they have as many companies do these days, they have an entire section of data scientists. And data scientists are people that you want to just do data science. You don't want them to have to worry about, again, their infrastructure. You don't want them to have to worry about building their Docker containers. You want to be able to hand them a container, an image, and say, well, you can't hand an image, right? You want them to be able to pull an image, build the container, and be able to run it so that they can modify their specific algorithms or whatever it is that they're working on. And this was, when I first heard this example, it really struck out to me as being, of course we want developers to develop, but specifically for folks like, again, data scientists or who are very specialized in the work that they're doing, you want them to focus on that and just not have to worry about infrastructure pieces. And the last piece of our modern application design is having the application be networked. And this is almost inherent to microservices. One of the issues of building microservices is that they become more complex, and you have all these pieces that are now, they're loosely coupled but highly cohesive. And while there can be a performance impact on that, we're working to ensure that, again, with the smaller code bases, we've got easier to read and understand code. And so when these components themselves are networked, they are communicating directly, usually behind the firewall, sometimes using TLS if you need them to. But by doing this, we have smaller code bases, and the communication is now taking place over a resource like networking, which is readily available to us because of virtualization. And that's actually, resources are something that we'll be talking about in an upcoming slide as well. So those are the principles of the modern application. Now we'll talk about the microservices network architectures as part of the maturity model. And we'll see how each of these concepts that we just talked about, the size being small, the developer orientation, as well as the networked pieces all fit in together. So has anybody seen a diagram like this before? Or how many of you who are working on microservices have something like this, where you have your monolith and you know you want to get it over to microservices, and all these squares look great. It's just that green arrow in the middle that you're not quite sure how all the magic that happens there to get there. And actually this is nearly over 2 years ago now, in 2016 at NGINX Conf, our microservices reference architecture was announced. And what these are three architectural models for microservices. Specifically, we developed them to help with the migration from monolith to microservices. As we've spoken with more and more customers over the last couple of years, we've discovered that a lot of these customers are already either, they're building greenfield applications, which means that they don't really need part of this, or they are, like we saw today in Sydney's example, we saw that 60% roughly are using monoliths still, but 30% are in that hybrid place. And that's really been the interesting piece. Like I said, we designed this architecture to be a full microservices architecture, but as we've seen in practice, a lot of folks are decomposing their monoliths in such a way that they may not decompose them all the way down. They're pulling out the features that make sense, put them into microservices, and then there are just some pieces of legacy code that can't be broken down, or that they have decided that it's probably too expensive to continue to break down, and they can run it as it is in a VM or a container and still interact with the services that they've been building. So that was a really interesting discovery for me as I spoke with microservices spoke about microservices, because I always thought, why not just build that shiny new great thing as part of your digital transformation? And so again, and I think for those of you who are business folks or even engineers in the audience, you probably understand that, again, sometimes the plan doesn't always go the way that you want it to, or another plan is more cost effective, or it works out better for one reason or another. So let me walk you through each of these very quickly. The proxy model is what we call it's the entry stage into migrating a monolith to microservices. What we see in this diagram is actually a more mature version of the proxy model. It shows a fully decomposed monolith where NGINX Plus is load balancing the external or the north-south traffic into your DMZ or your firewall, and managing that traffic to the service or the services themselves. What we see as a result of this is that the services are left to communicate with each other. And so, if you remember from our previous slides, that doesn't give us service discovery or load balancing. So once the decomposition has already happened, in order to get that service discovery and load balancing, the next step is what we call the router mesh. Router mesh is a hub and spoke model. In this particular case, this is more of a conceptual design. In practice, we would definitely have a highly redundant or highly available pair. And so we would have, again, two instances of NGINX handling that external north-south traffic, and 2 instances of NGINX load balancing or managing the traffic internally, the east-west traffic between the services. So when we compare this model to the previous model, we see that the services themselves don't need to communicate directly with each other at all. And we can now use that DNS configuration inside of NGINX, or functionality inside of NGINX, so that as multiple services, instances of services are created, NGINX can discover and load balance the traffic to those services. So that's really where we start to see some of the functionality and the features that we need for a microservices architecture. And then the final design is the fabric model. This follows a sidecar pattern. Have you all heard of the sidecar pattern inside of microservices architecture? So for those of you that haven't, a sidecar is inside of a container. Well, it doesn't actually have to be inside of a container. It can be inside of a VM, but it runs alongside of the business logic of a microservice, and it generally modifies the behavior of that service itself. So in this particular case, NGINX is handling all of the networking traffic. Over here on the right, we see a zoomed in. There we go. Okay, we see a zoomed in view of one of the services. The gray arrow is the service communicating directly with NGINX. And the green arrows, or in that green corner piece, is NGINX handling all that traffic. So you can think of this if you've implemented NGINX, you can think of this as being very similar to running NGINX on a server and load balancing traffic to another server, an upstream instance. In this case, there's only one upstream instance. And what this gives us, in addition to the service discovery and the load balancing, is secure TLS communication between each of the services. So we have several customers who, either by regulation or by business requirements, must have TLS between their services, even behind the firewall. And this allows us to implement that. Furthermore, if we create the certificates for each of the services and deploy them out to NGINX, we can support MTLS as well. So this is what we call the fabric model, and what we can see here is some parallels to the data plane of the service mesh. There was quite a bit of conversation about a service mesh this morning, and we have several conversations with customers about building out a service mesh and what that entails and what is required for a full service mesh. And so this is the beginning of, again, the data plane of the service mesh. There's also the control plane, which this currently doesn't address. But as you saw this morning, we're working towards that. So those are our three architectures that are, again, designed to help migrate from a monolith to microservices. When we put these into the context of those three principles for a modern application, we begin to see that we have our small pieces of code. They're all networked, and as a result of the code, the services themselves being small, we're developer-oriented. One piece of this is that this was developed in an orchestration-agnostic way. So when I first started at NGINX, we were building this out using DCOS. Since then, Kubernetes has become the most popular of the orchestration software. And so we've also built this out on Kubernetes as well. So once we bring the orchestration piece into this, we begin to see that the DevOps part, where developers don't have to worry about the infrastructure, they can write their services, push the code to GitHub, or push the code to a Git repository, not necessarily GitHub. And from there, the CI/CD will begin to take over. So that takes us into the next section, components of a pipeline for continuity. Continuity, again, in this case, talks about that continuous part of integration and deployment slash delivery. So let's talk about what it takes to do that. So for development, we have our repositories. It can be Git, Subversion, Mercurial. In my experience, I would say probably 90% of our customers are continuing to use Git. We've got containers and images, and so my first experience with containers were that I could build and run my applications locally without having to muck with my development environment. It was a natural progression to see orchestration taking advantage of that so that we could run a hypervisor or something so that it could run, again, that container without having to modify dependencies on the system itself. The next piece that we have is registries. So container image registries. When we create our images, we need to push those somewhere. And those registries, again, the most popular is Docker Hub. We saw a slide this morning that had Quay.io on there. Google Container Repository. Amazon has their own ECR registries. And then oftentimes we see customers running their own private Docker registry server. So for the development part, this is some of the basic components that are required. I promised you earlier that we'd talk about machine resources or resources in general. We've got compute power, which consists of virtual machines, the memory of a machine that we allocate to a container when it's running during its runtime. Those are the two main pieces when it comes to the compute power, memory and the CPU. The other piece is storage. Again, when we're running our workloads, they're generally running on a node somewhere, and there can be storage attached to those, and that's where we can, if we're running a database, we can store it there. It's been interesting to talk with customers about how deeply they integrate their storage with their orchestration software. We're finding that not many are, but there are a lot of solutions out there where companies are beginning to take advantage of the container storage interface, which is I believe it is an open source project, but I know for certain that it's a special interest group inside of Kubernetes as well. And so what this is doing is defining a standard for creating storage on nodes inside of orchestration software. And then the last piece, again, is the orchestration. I never have a conversation with customers that doesn't include Kubernetes. So we've gotten a lot of experience internally with using it. And it has proven to be very powerful and easy to deploy to, although I found that Kubernetes alone is not enough to continue to really build out this full continuous deployment process. So the last piece is, second to last piece is the CI/CD workflows. When we do continuous integration, we talk about being able to commit some code to a repository that is picked up by a build server, and that build server will then build the code, create the image, and run tests against it, so that we can see that if there were any changes or when those changes were made to the code, especially if we're talking about a refactor. In a refactor, we would expect the code to behave the same. And in that case, when we're running those tests, we want to make sure that those changes haven't affected the actual the functionality of the application. When we talk about continuous deployment and delivery, we're talking about now that the code has been built and tested, can we push it out to our orchestration, and will it run out there? And so we see one of the pieces here that we saw this morning was talking about canary versions. And so robust continuous deployment or delivery is version aware. And so one of the features that NGINX can do is we have a split client directive so that we can shape that traffic in a canary deployment, or if we want to talk about that, when we were talking about Spinnaker this morning, there were the red, black, or green, blue deployments. We can send percentages of traffic to different versions of our new code and before that code is fully deployed out to production, so that we understand the behavior and making sure that it's working properly. The last piece, which I wish I could talk more about today, I just didn't build enough time into this, but is the security. We get a lot of information, or a lot of people talking about DevSecOps, so developer security operations. And there are some really key factors here. One is being able to restrict the actors which can deploy images to runtime environments. This means that you don't want anybody just being able to push out a container or an image to your production environment. One of the more nascent features, I'd say, is code signing for images. So this is attestation. A company called Aqua is, I think, leading the charge on this, but they're not the only one. When we talk about the attestation process, there's also Spiffy and Spire, which are two protocols, open source protocols, that are being developed to ensure that in that control plane of our architecture, that that only certain services are allowed to communicate with each other. Again, this is it's fairly new stuff, but the team that's designing the specification for it is doing a really good job, and it's an interesting thing to follow. So when we put it all together, initially this is the design that we saw with this microservices architecture. An engineer pushes the code to Git. That continuous integration, or Jenkins or Circle CI, detects that push. It builds the code, builds and tests the code. If everything's okay, it pushes the image to your registry, and then informs your orchestration, in this case Kubernetes, that it's ready it should pull this image down. Turns out this is considered to be an anti-pattern inside of the community. What we've seen more recently is a Getups operation. And so the main difference here is that we've got a secondary, actually we have two loops. We have our CI loop and we have our CD loop. CI means that I can push code as much as I want. It's going to, the integration server is going to build, test, run the code. It can push images. It doesn't necessarily have to, but based on the result, if everything is green, then we will want to push the image. And then the engineer makes a change to this config repository, which can also be in Git. And there are several Getups operators. This is a generic one, but actually Spinnaker can be considered a Getups operator, as can is Weave that actually came up with this notion of Getups. And so they have defined their own, as well as their own Getups operator, but there are also others. But the main thing here is this implements security, because previously we saw that our CI/CD system, our CI system, could push to Kubernetes. And that requires generating keys so that and then putting those keys onto your CI server, which effectively increases the surface area or of attack. So in this case, we have our Getups operator, which reads from the config repository, and when it sees that its current version is different from the requested version, it'll go through and update it'll have the orchestration pull in that new image. So with that, I think we may be short on time, but we can take a couple questions. But I want to take us back to the beginning. I hope that this helps to understand the full concept of when we talk about a mature microservices application. And again, we've got those questions of where do I want to be, where am I now, and what is my plan to getting where I want to be. So that's it. Were there any questions, by the way? Oh.
How much of domain-driven design is being used to define microservices?
I would say with customers that we've worked with, about 80 to 90%. I've seen very few cases where domain-driven design is not the de facto for building out microservices. But those cases exist for sure, and it really has to do with requirements in the architecture. But for the most part, it's domain. You have your user service, you have if you're an e-commerce company, you have your orders service or shipping service, and it's all broken out by domain models. It's a good question. We get that quite a bit.
You had a series of slides, the different models, proxy, router mesh, and data pattern. It wasn't clear to me whether those were sort of 3 different models that you would choose, or if it was a progression that most customers.
I'm glad you asked that question. I was kicking myself for not putting. We do have a progression slide in there, and I didn't put it in there. I will get you the slide deck with that additional slide in there. I think we're making slides available to everybody.
The answer is, it is typically a progression.
Yes, 100%. It's meant to be a progression for sure. And with each different stage comes more robustness, but also a bit more complexity. Yeah. Any other questions? All right. Well, again, thank you for attending, and I hope you enjoy the rest of the conference as well.